Okay, ladies and gentlemen, welcome back to the 2013 FRQ. We're going to be working on questions 3 through 6. So that means there is going to be no calculator. We have 15 minutes per question, and the goal is to get as many points as possible, right? We are not looking to be perfect. We are not going to get 100% on this, but let's maximize everything and let's learn our concepts, our formulas, so that we can actually get those easy points. So it says the twice differentiable function W models the volume of water in gigaliters. T is measured in days. But we're given a table with W prime, which is going to be a rate. As you can see by the units, is gigaliters per day. At T is equal to 30, there is 125 gigaliters of water in the reservoir. Use a tangent line approximation to W at 30 to predict the volume of water at 32. Okay, so right here, the concept is that we're working with a tangent line. And if you want to make a tangent line, you should know that you need a slope and you need a point. The tangent line is going to be built at t is equal to 30. So for the slope, I need to find w prime of 30, which is given to me in the table. So that's 0.5. Now my point at 30, since t is technically like my x coordinate, we're going to have 30 right here, and we need to figure out how much water there is. And if you read the problem carefully, and if you underline all the information given to you, we know there is 125 gigaliters at 30. So now my tangent line. We're going to use y equals m, x minus x1 plus y1. We already figured out the slope is 0.5. x1 is 30. And y1 is 125. There's your tangent line. This question is only worth 1 point, so we haven't earned it yet. Next, we're going to go ahead and plug in the 32. Y is equal to 0.5 times 32 minus 30 plus 125. Just go ahead and simplify this down. 0.5 times 2, that's a 1. 1 plus 125 is 126. And that is how many gigaliters are in the reservoir. How do you spell reservoir? Reservoir at t is equal to 32. It's kind of a lot of work for 1 point, but every point helps. Use a left Riemann sum with 3 subintervals to approximate the integral from 0 to 30 of w prime dt. All right, let's go ahead and do that. W prime dt. A left Riemann sum, a right Riemann sum, an M Riemann sum. They're all rectangles. So we're going to do base times height plus base times height plus base times height. There's my 3 subintervals. The base is the difference between the x values, or in this case, the t values. And the first base is 10 minus 0. For the height, because we're using a left Riemann sum, you're going to have to use the left value, which is 0.6 plus. The next base is 22 minus 10. And we have 2 choices for the height. We're going to have to use 0.7. Finally, the base is 30 minus 22. And the base is, no, the height is 1. And I would just work it out. And times 0.6 is 6. 12 times 0.7, that's 84, so 8.4. 8 times 1 is 8. 16 plus 6 is 22. 22.4 gigaliters. But I didn't finish reading the question, so let's see. Use this approximation to estimate the volume of water in gigaliters in the reservoir at T is equal to 0. Okay. Calculating the integral of a rate gives us the net change, which means the amount in the water in the reservoir changed by 22.4 gigaliters from the starting point to the end point. So we added water. If I want to figure out how much water we started with, we're going to do the amount of water at T is equal to 30 minus the net change. And that's going to give us the amount of water at T is equal to 0. At the beginning of the problem, they told us there's 125 gigaliters of water at T is equal to 30. And we just figured out that we added 22.4 gigaliters in the span of 30 days. So if you subtract those, we get 102.6. 102.6 gigaliters at T is equal to 0. That's how much water we started with. Then we added 22.4 in the span of 30 days, giving us 125 on day 30. C. Explain why there must be at least one time other than T is equal to 10 such that W prime of T is 0.7. So if you look at your table, we actually have that W prime of 10 is 0.7. That's why they're saying that there has to be at least one other time. So the first thing you have to do is say that W is continuous. Since W of T is differentiable, that implies that W of T is continuous. So you have to build your argument as you go, right? You can't just state the result if you don't say that it's continuous. By saying that it's continuous, we know there's going to be no gaps, no jumps, no holes. So we're going to hit every value. And since W prime of 22 is equal to 1.0, comma, and W prime of 30 is equal to 0.5 by the intermediate value theorem, there must be a value C. You can call it whatever you want, but we're going to say C, such that W prime of C equals to 0.7. That's all you have to say. We already said the function was continuous. And I gave you a value that is greater than 0.7, and I gave you a value that is less than 0.7. So your function would have to go through 0.7 at some point. We stated that it was continuous. We stated the theorem that applies. That will give you all your points. Oh, one side comment. Remember the differentiability. Differentiability, did I spell that correctly? Implies continuity. But continuity does not imply differentiability. So keep that in mind moving forward. Okay. Trying to fix this right here. I think something messed it up, but I guess not. Differentiability. Come on, there we go. The equation A gives a relationship between the area in square kilometers of the surface of the reservoir. Find the instantaneous rate of change. See, sometimes I'm looking for the keywords. Like I kind of skipped all the sentence. I'm like looking for what it's asking me to do, and it's telling me to find a derivative. We're gonna take the derivative of A with respect to time per day. So if A is equal to 0.3 W to the power of 2/3, that means that dA dt is going to be 0.3 times 2/3 of W. And then we're going to subtract 1 from the exponent. And here's the mistake that I saw a lot of students do. We're taking the derivative with respect to time. And this is not time. It's a function. So you have to use the chain rule times dW dt. Now we can go ahead and plug in the 30. dA dt at t is equal to 30 equals, well, we're going to go ahead and multiply these two. 0.3 times 2 is 0.6 times 1 over the cube root of W. See, W is not T, right? So we can't plug in 30 right there. So I'm going to keep it as W times dW dt. I actually have no place to plug in the 30. But if we go back to the problem, we can actually figure out what W is at 30. W is 125. So this equals, well, 0.6 divided by 3 is 0.2 times the cube root of 125 times dW dt. Oh, and I can actually go back to the problem and figure out what that is, because we're trying to figure out W prime at 30. That we can find on the table. So times 0.5. 0.2 times 0.5, that's 0.01. And the cube root of 125 is 5. So 0.1 divided by 1 over 5. Well, 0.1 is 1 over 100. And that equals 1 over 500. Just making sure I got the correct answer here. 0.2 times 0.5, 0.1. 0.2, 0.1, 1 over 5. I feel like I made a mistake here somewhere. Let's see. 0.2, 0.5, 1 over 5. Because if I go back and I just find this and leave it as 1 over 5, 1 over 5 times 0.5 is 0.1, and 0.2 times 0.1 is 0.02. That is not the same as 1 over 500, but this is the correct answer. Okay. Number 4. Let f be the function given by f of x. Find the limit to infinity and find the limit to negative infinity. All right. So if I try to find the limit to infinity, you're essentially plugging in really, really, really large numbers into all the x's. And x squared minus 2x minus 1, well, that's basically going to be infinity. E to the power of infinity is also infinity. It's just infinity. You can also say it doesn't exist. Since the limit is not an actual number, we can say that it does not exist. Okay. Now we plug in negative infinity. If I plug in negative infinity, x squared is going to make it into a positive. So it's, okay, let me just set it up. Negative infinity squared minus 2 times negative infinity minus 1 times e to the negative infinity. Squaring a negative makes it a positive. These negatives become a positive. But even if it wasn't, even if it was negative, it still would be insignificant because this one grows much, much faster. But in this case, we still have infinity. The interesting part right here is e to the negative infinity. Since we have a negative exponent, we can bring it to the denominator. And now you have to make a decision. Does the numerator grow faster, or does the denominator? The denominator grows faster because exponential functions grow significantly faster than quadratics and linears. Oh, why am I writing denominator? I meant to write big. Small over big. The denominator grows significantly faster. So small over big is always going to be 0. We get, oh, we only get 1 point for this one. They both have to be correct. Find the intervals on which f is increasing. That means I'm going to find my derivative. I'm going to set it equal to 0. I'm going to find my critical points, and I'm going to do my number line. So f of x equals x squared minus 2x minus 1 e to the x. So my derivative, we got to use the product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. Then you're going to set it equal to 0. But you got to get a little clever here, because if you just try to solve it the way it is right now, it's going to be very, very hard. The trick here is to factor out an e to the x, leaving us with x squared minus 2x minus 1 plus 2x minus 2. The 2x's cancel each other out, leaving us with x squared minus 3. And now that we have factor form, you can set each factor equal to 0 and solve for x. The first one has no solution. And the reason for that is because if you take the natural log, ln of 0 is undefined. So we get no critical points from that. But with the second factor, we're actually going to get 2 critical points. We get plus or minus the square root of 3. So like I told you, first you want to find the derivative. Then you want to show that you're making it equal to 0. Then you find your critical points, and next you do your number line. Negative square root of 3, square root of 3, and we're going to plug in numbers into my derivative so we can figure out if it's positive or if it's negative. Okay. You have 2 options here. You can plug in your values into this one because that is the derivative. But my recommendation for you guys is to always work with factor form. Factor form makes it a lot easier. So take a number such as negative 10. Okay. We're gonna say f prime of negative 10 equals, when you plug it into the e to the negative 10 is positive because all it does is make it into a fraction, but it's still positive. X squared minus 10, minus 3. Well, the x squared is going to make 10 into a positive, right? It's going to be 100 minus 3. It's a positive. And a positive times a positive is a positive. Okay. Now we're going to plug in 0. f prime of 0, e to the power of 0 is 1, or in other words, positive. 0 squared minus 3, well, that's a negative, so we get a negative. And then you can plug in something bigger than radical 3. E to the power of 10 is positive. 10 squared minus 3 is positive, so we get positive. So on which intervals is f of x increasing? F is increasing on the interval from negative infinity to negative square root of 3 and the square root of 3 to infinity, because f prime of x is positive. And we get 4 points out of this. We get 2 points by finding the correct derivative. We get 1 point for, it says analysis. So what I'm thinking is for the critical points. And then 1 point for the answer. Okay. Find the intervals on which the graph is positive down. It's basically the same question as the previous one. We said the derivative was, we factored out an a to the x, and we were left with x squared minus 3. So that's where we left off. And for concavity, we're going to find our second derivative. We're going to set it equal to 0. We're going to find our critical points. And we're going to do a number line. Those are all the steps we're going to do. So my derivative, I'm going to get through the product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. And just like in the previous problem, we're going to get a little clever. We're going to go ahead and factor out e to the x. That's our greatest common factor. F double prime of x equals e to the x, 2x plus x squared minus 3. Set it equal to 0. X squared plus 2x minus 3. Factor out the polynomial if possible. If not, we're going to have to use the quadratic formula. But let's see, two numbers that multiplied are negative 3, added to positive 2. Set each one of them equal to 0. The first one, we already established that we can't solve it. So there's no critical points. But we get a critical point at negative 3. And we get a second critical point at positive 1. Now the number line. Negative 3, positive 1. But this time we have to use the second derivative because we're looking for concavity. To figure it out, I'm going to be using the second derivative in factor form. That makes it super, super easy for me to figure out if it's positive or negative. So let's plug in negative 10. E to the power of negative 10 is positive. Negative 10 plus 3 is negative. Negative 10 minus 1 is negative. And all of this gives me a positive. 0. E to the power of 0 is positive. 0 plus 3 is positive. 0 minus 1 is negative, so that's negative. The second derivative, and this time we're going to plug in 10. E to the power of 10 is positive. 10 plus 3 is positive. 10 minus 1 is positive, so here we have a positive. So the function is concave down. F of x is concave down on negative 3 to 1 because the second derivative is negative. One side comment about your intervals. Your intervals have to have parentheses because -3 and +1 are not included in the interval, right? Well, those are actually critical points. If you plug in -3, you get 0. You don't get positive, you don't get negative, you get 0. So those are not included as a part of your domain. So make sure you're really careful with that because you might not get the point if you put brackets. Same thing with the previous question. No brackets. Brackets would mean those are included and the critical points are not included. The critical points give us 0. Not positive, not negative. They give us 0. Okay, number 5. Okay, let's see. What do we got? We got the graph of f. We have a function g that deals with an integral, and we're supposed to find g of -6 and g of 3. Okay, just go ahead and plug it into your formula. G of -6 is the integral from -2 to -6 for f of t dt. Now, when you do an integral, you're supposed to go from smallest to greatest. So we're going to flip it. So now we're looking for the area from -6 to -2. That right there is a triangle. So the area is -1/2 base. The base is 4, and the height is 5. So that's going to be -2, -10. G of 3. I'll do it in a different color so we can see the highlighting. G of 3 equals the integral from -2 to 3 of f of t dt. So that is going to be a semicircle and a tiny triangle. So 1/2 pi r squared minus 1/2 base times height. Oh, really careful because the triangle is below the x-axis. So that means your area is going to be negative. So 1/2 pi. The radius of the circle is 2. The base of the triangle is 1 and the height is 2. Technically it's -2, but I already wrote my negative right here, so I don't have to say it twice. There we go. That's going to be 1/2 pi times 4 minus 1, which is 2 pi minus 1. That gives us 2 points. Find g prime of 0. Well, first you have to write what g of x is. And g of x is the integral from -2 to x of f of t dt. Find your derivative first, right? Don't go and say g prime of 0 right away if you haven't found your derivative. So derive. That's going to cancel the integral, and it's going to cost you to plug this guy in. Now, technically, you're also supposed to multiply times the derivative of whatever you plugged in. But that derivative is technically just a 1. So it's just f of x. Now you plug in your 0. G prime of 0 is wherever f of 0 is. And if you look at your graph, f of 0 is 2. Okay. Find all the values of x on the open interval where the graph has any horizontal tangents. Determine if it's a maximum, a minimum, or neither. This question is basically the same thing as question number 4, where you take your derivative, you set it equal to 0, you find your critical points, and then you do your number line. Okay, so g of x equals the integral from -2 to x of f of t dt. find your derivative. You set it equal to 0. Now use the graph. When does f of x equal 0? I see 3 points. -6, -2, and 2. Okay. Then you do your number line. Determine whether G has a local max, a local min. Okay. Well, -6 is actually an endpoint, so we're not going to go to the left of it. -6 is the endpoint. -6. -2, +2. And we're supposed to be plugging the numbers into the derivative, G prime, which is f of x. So G prime of, say, -3 is the same thing as finding f of -3. F of -3 is a positive number. I think it's 2, but I can't really tell, but I know it's positive for sure. So positive. G prime of 0 is the same thing as f of 0. F of 0 is 2, so that's a positive. G prime of 3 is the same thing as saying f of 3. That is a negative. So where does G have a local max and a local min? Well, if you think about the shape of the graph, your graph starts somewhere, and the first thing it does is increase. So increases, and it briefly stops. But then it continues increasing, and then it stops. And then it starts to decrease, and it stops. So but one more thing. Come on, computer. Don't glitch on me. Oh, it's freezing. Okay, I think we're back. Uh-oh, let me see. Close the program. Oh, sorry, ladies and gentlemen, technical difficulties. Let's go back. Okay, good. My work is still, for the most part, saved. Oh, no, that was, it was still increasing. So it says that we're supposed to find the values of x on the open interval from -6 to 3. The open interval. So technically, that means -6 doesn't qualify as a minimum. So we're just focused on -2 and 2. G has neither a min or a max at x equals -2 because G prime doesn't change signs. We went from positive to positive, so that was no critical point. G of x has a local max at x equals 2 because G prime of x goes or changes from positive to negative. Okay. D. Find all the values of x on the open interval where G has a point of inflection. Okay. It's basically the same question, right? So we left off by saying that the derivative was f of x, right? Yeah. f of x. So my second derivative is f prime. We set it equal to 0. And we figure out the critical points. Since we're looking at f prime and the graph that we have available is the graph of f of x, you guys need to look at the slope of f. So when does the slope equal 0? Or when, or technically also where it's undefined. We have -4, we have -2, and 0. We have -4 because the slope is undefined. We have a corner. We have -2 because we have another corner or a cusp. And at 0, we have a horizontal tangent line. So the slope is 0. And technically at 2 as well, because we go from like a circle to a straight line. So technically the slope is undefined. Undefined. -4, -2, 0. So what do we say? -4, -2, 0. Okay. That's interesting. The solution doesn't say that 2 has a critical point, but the slope technically is undefined there. So I'm just going to go ahead and write it. All right, so now that we have our critical points, we're going to do our number line. -4, -2, 0, and 2. And we're going to be figuring out if g double prime or f prime is positive or negative. So before -4, if you look at the slope of the graph, the slope is positive. Then the slope is negative. Between -2 and 0, the slope is positive, negative, and then still negative. So what was the question? G has points of inflections. G of x has a point of inflection at x equals -4 because G double prime goes from positive to negative. Another one at x equals -2 took me all the way up there. We have another point of inflection at x equals -2 because G double prime changes from negative to positive. We also have a point of inflection at x equals 0. I'm going to go ahead and put it right here because of the same reasoning, because G prime goes from positive to negative. And that's it. So here, it's kind of like a package deal right here, right? Because the reasoning is the same. We go from positive to negative. Okay. I don't think I'll have enough time to go over number 6. Let's give it a try. It's only 2 parts. Write an equation for the line tangent to the graph at the point x equals 2. Okay, let's speed it up a little. First, I'm going to have to find my derivative. And here, we're given the slope of f. So, f prime of 2 equals 3 times 2 to the power of 2, but we have to know the y value. But they give it to us, right? Look at this. F of 2 equals negative 8. So my y value is negative 8, which means my slope, 4 times 3 is 12, which is divided by 4 is negative 3/2. That's your slope. We already have the point. So my tangent line is going to be negative 3/2 x minus x1 plus y1. And then we're going to use it to approximate f of 1.8. So negative 3/2, 1.8. Oh, that's not a plus, that's a minus. (1.8 minus 2), that's 0.2. Oh, negative. 0.2. That's 2/10. That's 1/5. That's negative 1/5. That's going to give us positive 3/10. And I'm going to go ahead and get a common denominator for 8. So that's going to be 80 over 10, which becomes negative 77 over 10. You can leave it like that, or you can give it as a decimal, negative 7.7. That's 3 points. One for the slope, one for the tangent line, one for the approximation. Okay, now the last one. The one that we've been bombing a lot lately. Actually, this one wasn't that bad because we improved it. Find an expression for f of x if we were given this differential equation. You got to separate the variables. dy dx equals 3x squared over y. I'm going to multiply y. I'm going to multiply dx. That gives you 1 point. Then we're going to find the antiderivatives. That should give you 2 extra points. Then we're going to plug in our point so we can figure out c. 1/2 negative 8 squared equals 2 cubed plus c. That's going to be 64. 64 over 2 is 32. C equals 24. So now we can go back and we can complete our equation. X cubed plus 24 multiply by 2. Take the square root. And technically that's your answer. But when you take a square root, you get positive or negative. And here my point has a negative y value. So your answer should be negative square root of 2x to the power of 3 plus 48. Once again, because of the negative 8. Oh, I barely finished. All right. Thank you very much. Hopefully I'll see you guys tomorrow for Saturday school. You're more than welcome to come. BC is going to be doing a test tomorrow. So you're going to sit back and study. Thank you. Hasta luego.